Before we get into what James Webb actually found, I need to tell you what that headline is claiming, because it's worth being precise about it. Mysterious metal objects surrounding 3I Atlas implies the James Webb Space Telescope photographed something artificial, structures, debris, hardware, physically orbiting or accompanying an interstellar comet. That has not happened. No image, no paper, no NASA release, no ESA release describes anything resembling metallic objects around 3I Atlas. What Webb has actually found is, in its own way, considerably stranger and considerably more interesting than a fabricated one. And there's a real, ongoing, very public scientific controversy attached to this object that a lot of clickbait content is clearly trying to piggyback off of, without doing the work of explaining it properly. So let's do that instead. To understand why 3I Atlas became such fertile ground for speculation in the first place, it helps to know a little about the two interstellar objects that came before it, because the pattern repeats almost exactly. The first, Oumuamua, was discovered in 2017, the very first confirmed interstellar visitor ever detected passing through our solar system. It was small, elongated, tumbling, and its trajectory showed a slight, unexplained acceleration as it left the solar system, an acceleration that didn't perfectly match what pure gravity alone would predict. Most astronomers attributed that acceleration to outgassing, the same jet-like release of gas that powers ordinary comets, even though Oumuamua's outgassing was never directly detected the way it normally would be. Avi Loeb was one of the researchers who argued that gap in the data left room for a more exotic explanation, eventually co-authoring a paper suggesting the object's behavior was consistent with a thin artificial solar sail, a proposal that made international headlines and turned Loeb into arguably the most publicly recognized voice, arguing for taking the search for alien technology seriously within mainstream astronomy. The second confirmed interstellar object, Borisov, arrived in 2019 and behaved almost exactly like an ordinary comet in every measurable way, generating far less controversy. Then came 3I Atlas in 2025. Larger, chemically stranger, and arriving into a media environment where Loeb already had a large, engaged public following primed to consider the artificial origin question seriously the moment any unusual behavior showed up. That history matters, because Loeb didn't invent his approach to 3I Atlas from nothing. He's applying the same framework he developed studying Oumuamua, formalized through something he calls the Loeb scale, a proposed ranking system meant to score how strongly a given piece of evidence for or against artificial origin should be weighted. Through his work with the Galileo Project, a research initiative he leads focused specifically on searching for physical evidence of extraterrestrial technology, Loeb has pushed for exactly the kind of direct, testable observations that ended up happening here. The Green Bank radio search being one concrete example of his general approach actually being put into practice, rather than staying purely theoretical. 3I's Atlas is real. It's the third interstellar object ever confirmed passing through our solar system, following Oumuamua in 2017 and Borisov in 2019, and it was first detected on July 1st, 2025, by the Atlas Survey Telescope in Chile, in a set of exposures taken between 5:15 and 6:20 in the morning, Chilean time, a routine automated sky survey run that happened to catch, almost by accident, only the third confirmed visitor from beyond our solar system in the entire history of astronomy. From the very beginning, its orbit gave it away as something that didn't originate here, a hyperbolic trajectory, meaning it's moving too fast, on too open a path, to have ever been gravitationally bound to our sun. It came from somewhere else, it's passing through, and it is never coming back. Early observations showed it had a reddish spectral color, similar to the two interstellar objects discovered before it, and a nucleus somewhere between roughly 440 meters and 3. 5 miles across, based on the range NASA's own Hubble observations were able to narrow down by August of 2025. It made its closest approach to the sun in the latter half of 2025, and by December, it had passed too close to observe from most instruments and then began swinging back outward, on its way out of the solar system permanently. That closest approach is actually the key to this entire story, because it's what made the real Webb observations possible in the first place. As 3I Atlas passed near the sun, the heat did something predictable to any comet, interstellar or otherwise. It warmed the object's surface ice, which sublimated directly into gas, forming a glowing cloud around the nucleus called a coma. That coma is where almost all of the genuinely fascinating, entirely natural chemistry in this story comes from. On December 27th, 2025, once 3I Atlas had moved back out to roughly 379 million kilometers from the sun, astronomers turned the James Webb Space Telescope's MIRI instrument toward it and captured something Webb had never captured from an interstellar object before, a detailed mid-infrared chemical fingerprint freshly released by the warming ice, ready to be measured. What Webb found first, in results NASA published through its own science division, was methane, detected directly in the comet's coma, marking the first time this specific instrument had picked up that particular gas coming off an interstellar visitor. That alone was a genuine milestone. Methane detection requires exactly the kind of infrared sensitivity Webb was built for, and it gave researchers a direct look at part of the comet's original chemical makeup, frozen since before it ever encountered our sun. Those results were published in the astrophysical journal Letters, a peer-reviewed journal with NASA's own science division describing it as Webb's first mid-infrared chemical fingerprint of any interstellar object. But the finding that actually reshaped how scientists think about where this thing came from arrived a few months later in a follow-up analysis published on June 22, 2026, in the peer-reviewed journal Nature. That paper focused on something specific and, frankly, kind of remarkable: the ratio of carbon to deuterium. Deuterium being a heavier form of hydrogen, sometimes called heavy hydrogen, captured in 3I Atlas's chemical signature. According to the research team's own description of the results, those ratios don't match anything found in comets native to our own solar system. They're distinct enough and unusual enough that researchers were able to work backward from the chemistry itself to estimate the environment this object originally formed in, long before it ever entered our neighborhood. Their conclusion, published in one of the most rigorously reviewed scientific journals in the world: 3I Atlas likely formed somewhere between 10 and 12 billion years ago. For context, our own solar system is about 6 billion years old. If that estimate holds up, this object is older than the Sun, older than Earth, older than most of the stars currently visible in our night sky, a fragment of ice and dust that has been drifting through interstellar space, essentially unchanged since a period when the universe itself was still young. That's not a manufactured mystery. That's a directly measured, peer-reviewed, published result, and it's a genuinely bigger claim than metal objects ever needed to be. NASA's own description of the findings put it plainly. The comet formed in a distant part of the galaxy under conditions that looked nothing like the environment that produced our own solar system. It's worth spending a moment on why a ratio between two forms of hydrogen can tell scientists something as specific as an object's age and birthplace, because the logic behind it is genuinely elegant once you see it laid out. Deuterium is heavier than ordinary hydrogen, and the balance between the two isn't fixed across the universe. It shifts depending on the temperature and density of the environment where ice originally formed, billions of years ago, before it ever became part of a comet. Colder, more ancient environments tend to lock in a higher proportion of deuterium relative to ordinary hydrogen than warmer, younger ones do. By carefully measuring that ratio in 3I Atlas's coma and comparing it against ratios already cataloged from comets known to have formed in our own solar system's early history, the research team was able to work backward to an estimate of both the temperature and the age of the environment. This specific ice originally condensed in, arriving at that 10 to 12 billion year figure not as a guess, but as a calculation built directly from measured chemistry. That's the kind of result that ends up in Nature specifically because the method is rigorous enough and the implications big enough to survive intense scrutiny from independent reviewers before publication. Webb wasn't the only instrument involved in building this picture either, and it's worth naming the others because it shows how much independent cross-checked observation actually went into this, rather than one telescope's word taken alone. NASA's SPHEREx mission, observing in December 2025 as well, detected infrared light from organic molecules directly within the comet's coma. Carbon-based compounds, the same broad chemical family that life as we know it is built from, though finding organic molecules in a comet is common and not, on its own, any kind of biological signal. The Hubble Space Telescope had already been tracking 3I Atlas since July of 2025, capturing a teardrop-shaped cocoon of dust streaming off the nucleus and helping pin down its size estimates. Ground-based observatories, including the Gemini North Telescope in Hawaii, captured their own direct images of the object as it moved through the sky in late November 2025. And in April of 2026, radio observations using the ALMA array, a massive network of radio telescopes in Chile, detected record-high levels of methanol coming off the comet, adding yet another data point to the growing chemical profile astronomers have been assembling piece by piece across multiple instruments for the better part of a year. Alongside Webb, Hubble, and SPHEREx, NASA also redirected its TESS spacecraft, normally used to hunt for planets around other stars, watching for the tiny dip in brightness a planet causes as it crosses in front of its star, for a dedicated observation run, specifically studying 3I Atlas's activity and rotation. Multiple independent ground-based teams worked out the object's rotational period using different telescopes and different methods. One team, using the Gran Telescopio Canarias in the Canary Islands, calculated a rotation period of roughly 79 hours, while a separate team, working with the Southern African Large Telescope and the Nordic Optical Telescope, independently arrived at a very similar figure of about 16 hours. That kind of independent convergence from separate instruments on separate continents is exactly the sort of cross-checking that gives a measurement real scientific weight. It's not one group's number taken on faith, it's multiple groups landing in the same narrow range using different equipment entirely. Photometric monitoring also showed the object's brightness stayed relatively flat over time, with a light curve pattern and reddish coloring consistent with what had already been seen in both Oumuamua and Borisov, suggesting whatever unusual chemistry 3I Atlas carries, its basic physical behavior as a spinning, tumbling chunk of ice and rock looks fundamentally ordinary. The specific technical objection Loeb has repeatedly raised centers on the object's non-gravitational acceleration, meaning its trajectory shows small deviations from a path shaped by gravity alone. Deviations that, in an ordinary comet, get attributed to the thrust created by jets of gas escaping unevenly off a rotating, sun-warmed surface. Loeb has argued that some of the specific numbers involved don't cleanly fit the standard outgassing model, and has also criticized certain publicly released NASA images as too low resolution to definitively rule out alternative explanations for the object's fine structural details. Researchers who disagree with him haven't simply dismissed the numbers, they've pointed to fragmentation events, uneven surface composition, and the geometry of how jets project relative to our line of sight as sufficient explanations, arguing that comets, especially ones as chemically unusual and ancient as this one appears to be, often produce messier, harder to model outgassing behavior than the cleaner examples found closer to home in our own solar system. Nickel abundance became a specific flashpoint in this back and forth as well. Loeb pointed to certain nickel-related readings as part of his case for taking anomalous explanations seriously, while other researchers have argued that improved, higher-resolution follow-up data brought those specific readings back in line with what's expected from an unusually composed but entirely natural object. None of that back and forth is settled by shouting past each other, and it hasn't stayed confined to blog posts and social media threads. Both sides of this disagreement keep publishing new data in public in real time, as new instruments get pointed at the object during its rapidly closing observation window, which is exactly why an April 2026 update was even possible to report on at all, with new ALMA methanol measurements and new images from ESA's JUICE spacecraft, captured as it happened to pass near Jupiter, adding fresh material to an argument that neither side has walked away from. So here's where the actual sourced version of this story leaves us, as of the most recent published research. James Webb didn't photograph metal objects surrounding an interstellar comet. It photographed and chemically analyzed a genuinely ancient piece of interstellar ice and dust, likely older than our own sun, carrying a chemical signature unlike anything native to our solar system, releasing methane and methanol and organic molecules into a glowing coma as it swept past the sun on a one-way trip that started somewhere else in the galaxy roughly 10 billion years before Earth existed. That story got tangled up publicly with a genuine, ongoing, credentialed scientific disagreement over whether some of its behavior might warrant consideration as artificial, a disagreement that has so far been tested directly, including with a dedicated radio search that came back empty, and that the majority of the reviewed, published scientific literature does not currently support. Neither of those two real threads, the ancient natural chemistry or the contested speculation about artificial origin, needed a fabricated image of metal debris to be worth 15 minutes of anyone's attention. The real story already had a Harvard astrophysicist publicly arguing a minority position against the mainstream of his own field, a dedicated alien signal search actually being run and coming back with a clear result, and international teams of scientists racing against a closing observation window to squeeze as much chemistry as possible out of an object that will never pass this way again, because once 3I Atlas leaves the solar system, there's no bringing it back for a second look. That's the actual stakes, not manufactured ones. There's also a broader reason this particular object matters beyond the controversy attached to it, and it's worth naming directly before we close. Every interstellar object that passes through our solar system is, in a very real sense, a free sample delivered from somewhere else in the galaxy, material that formed around a star we'll likely never visit, shaped by conditions we can otherwise only model theoretically. We have now confirmed exactly 3 of these visitors in the entire history of astronomy, and each one has taught scientists something the previous one couldn't. Oumuamua raised the question of what these objects even look like and how they move. Borisov confirmed that at least some of them behave exactly like ordinary comets, chemistry and all. And 3I Atlas, with its unusually ancient deuterium signature and its detectable organic and methane chemistry, is now giving researchers their first real detailed look at what ice actually looked like billions of years before our own sun ignited. A genuinely rare kind of data point that no amount of modeling or simulation can substitute for. If you want to check any of this yourself, NASA's own science division has a dedicated, continuously updated page tracking every 3I Atlas observation across every mission involved: Webb, Hubble, SphereX, TESS, and ground-based observatories, with direct links to each published result. The methane detection is published in the Astrophysical Journal Letters. The ancient origin findings, including the carbon-to deuterium ratios, are published in Nature, one of the most selective and rigorously reviewed journals that exists. And Avi Loeb's own claims, along with the scientific community's responses to them, are publicly available in his own essays and in the direct rebuttals published by name from researchers like Daryl Seligman, Megan Schwamb, and Mark Norris. None of it requires taking a stranger's word for it, and none of it requires an invented image of metal wreckage to hold your attention. It's worth adding one more piece of honest context before we close this out, because it cuts against the tidy ending a lot of space content tries to force onto stories like this one. Loeb's specific hypothesis about 3I Atlas being technological hasn't been formally, decisively disproven in the way a headline might want to claim. What's actually happened is narrower and more interesting than a clean verdict either way. Every specific, testable prediction his framework has generated so far, a radio signal, a nickel anomaly, an unexplained acceleration that resists ordinary cometary modeling, has, when tested directly, come back consistent with a natural, if unusually ancient and chemically distinctive comet. That's not the same as saying the question is permanently closed. It's saying that, so far, every time the two competing explanations have gone head-to-head against real data, the ordinary explanation is held up, and the extraordinary one hasn't yet found the piece of evidence it would need to overturn that pattern. Given how quickly this object is moving away from us, and how few observation opportunities remain, that pattern may simply be the final answer we ever get. Not because anyone stopped looking, but because the target itself won't be reachable much longer. So here's the actual open question, and unlike a fabricated one, this one has real stakes attached to it. 3I Atlas is already moving back out into interstellar space on a trajectory that guarantees it will never return. And every instrument currently pointed at it is racing against a closing window that will, at some point in the coming months, close for good. Somewhere in the data already collected, the deuterium ratios, the jet activity, the anti-tail nobody has fully modeled to universal agreement yet, there's still room for genuine surprise, the kind that comes from careful, published, peer-reviewed science, rather than from a headline built to look alarming for 10 seconds of watch time. We are, right now, in the final stretch of humanity's only chance to study this specific dust from this specific corner of the galaxy, from an object that formed before our own sun existed. That's the real mystery. It never needed to be dressed up as anything else, and it certainly never needed metal objects that were never actually photographed by anyone on any mission at any point in this entire genuinely remarkable story.